the webinar is on Make IoT and Big Data Your Maintenance Assistants. I am Arunkumar Nair, Technical Head Big Data Analytics at MSys Technologies. So the agenda is the types of maintenance, especially industry and machine related maintenance, and then why we are using predictive maintenance, then how IoT and data collection is closely related to each other, and the impact that IoT has had on predictive maintenance. How do we predict failures? Then the other area we are going to cover is using machine learning algorithms to predict failure, and then we will have 10 to 15 minutes of Q&A session. So as a topic, predictive maintenance is quite large and in-depth. However, I have tried to cover as much as we can in this area and make it meaningful to all of you. So right from the beginning, we have different types of maintenance. Maintenance is primarily meant to keep the machine in proper condition. We have preventive maintenance. It is a kind of scheduled maintenance that the manufacturer tells the user so that you can extend the time and the life of the machine. Then we have condition-based maintenance, which I will also cover in depth in the succeeding slides. The maintenance is based on certain conditions of the machine. So for example, if a machine is running in a rugged zone, then the amount of maintenance interventions is higher. Finally, the new area of maintenance, which is there for a longer time now, the predictive maintenance, it is to use data to predict maintenance in advance and predict certain failures. So within predictive maintenance, we have two types, that is diagnosis and prognostics. So what does diagnosis mean in predictive maintenance? It is specifically to identify the causes of failure. And prognostics is predicting machine failure in the future of time. So the history of maintenance can be looked at in this format, that is generally you repaired when a machine failed, then preventive maintenance, which also included inspect, lubricate, and scheduled inspection and lubrication of components. Then predictive maintenance, which is scheduled maintenance based upon the probability of failure. Systematic planning and scheduling comes closely to condition based, and it is to provide feedback to improve maintenance. Like for example, if a service seems applicable or if any services has been missing. Predictive maintenance is again based upon data and prediction of failure. So this has been the history of maintenance. So why do we need predictive maintenance? It is primarily to detect the earlier symptoms of irregular functioning and machine breakdown. So if you see on a time chart, the cost of maintenance is very high when the failure happens. If you detect it early, when there are certain signals, the cost of repair is lesser. So how does predictive maintenance is different from traditional maintenance? Predictive maintenance primarily contains a continuous stream of data which is collected, and this data is used to predict the failure. So failure prediction happens when machine is failed so that further actions can be planned. Also, it is used for failure detection and diagnosis. Why is predictive maintenance growing? So predictive maintenance is growing because of IoT. There are a lot of manufacturers who have started building sophisticated IoT devices. We are having connected gateway products, and there is certain amount of standardization that is happening in the sensor world. Though the amount of standardization we need is a lot, but we are still moving in that direction. Also, we are able to move this data to the cloud, and definitely big data analytics helps us to analyze this data. So There were sensors always in the market, but now you can see the cost of sensors have been going down. That is why predictive maintenance has become very popular. My initial few slides are very generic and general in nature, but as we go through the slides, we will be covering the predictive maintenance and algorithms in detail. So what is the role of IoT data collection and what devices should we use? So data collection has become very important because of if we have to use it in predictive maintenance. So you can have various sensors which are fitted. You can see on the screen the various sensors which are fitted onto the machines, and we use a protocol to stream this data to the cloud. And in the cloud, we are analyzing this data to predict if they are going to fail. So how do we choose a IoT device? Now, the choice of IoT device depends on what kind of data we want to log, what are the values in the data log which will imply faults or errors, and what methods and values we need to find the reason for this fault or failures. So IoT data collection through users, most of the IoT devices that are there in the market are generally GSM and GPRS enabled. So some of the IoT sensors and the purposes for which they are used are power meter. IoT power meter provides accurate statistics on power consumption. Then we have temperature sensors that record the temperature. Humidity sensors for humidity, reed switch which records the whenever a door is opened or closed. Then passive infrared sensors for motion detection, it records when a human intervention happens. LDRs for the lighting inside a room. Proximity sensors when sensor has to detect a presence of an object without any physical contact, and of course the GPS devices. So IoT data collection, I've just put some high level information about certain devices which are there available in the market. These are, for example, a lot of devices are there also on our smartphones, but these are generally the industry devices, gyroscopes, which is used in smartphones to maintain the orientation of the smartphone. Then we have accelerometers, which is kind of a sensor that used to measure the acceleration. Then magnetometers for the magnetic field. Then pressure sensors. TPMS is a device used to measure the tire pressure, especially on vehicles. Then we have for the lighting micro mirrors. These are used in video projections in CCTVs. Then we have radio frequency related devices. RFID chips are very popular. RFID chips are generally used to identify and track objects. Then managing fluids and various other electromechanical systems are used in industry IoT. So what are the approaches to predict failures? There are two primary approaches to predict failures, the data-driven model and condition monitoring. So in data-driven model, we predict machines remaining useful life before the next failure occurs, predict if a machine will fail within X days, and predict if machine's condition is abnormal. So primarily we are using data-driven model here. Condition monitoring also uses data-driven model, but there is a lot of domain expertise or machine related knowledge that we have. So I'll just show you an example of what condition monitoring is there in the next slide. So condition based monitor looks at the condition of the asset to decide what maintenance needs to be done, and then it is performed when certain indicators show signs of decreasing performance of upcoming failure. Also checking a machine for these indicators and visual inspection, performance data. So it is a comprehensive way of predicting failure. We also use statistical models in condition monitoring. We will use sensor data. Like for example, if the sensor data tells us that it is exceeding a predefined threshold of machine cycles, then we should use predictive intervention. Also, it is generally formula driven based on the knowledge that we have on the machine. So in the next slide, I'm just showing an example of what condition-based maintenance is. For example, if machine comes from a manufacturer and the manufacturer recommends the interval of replacements. Now these intervals are based on the manufacturer's analysis and performance data. Now we can also use IoT sensors to decide which is the best average or best guess and decide of an intervention of predictive maintenance here. So predictive maintenance, the primary tool that is used is machine learning. So how does machine learning work? So we can retrieve a lot of data from the sensors which we shown earlier, such as vibration data, temperature data, the number of RPMs. And this data comes in, and we generally split the data into two parts, the training data as well as the test data, which I'll cover in the next slides. And this training data is fed into computers and a relevant training model is built. So some of the algorithms that are used are the linear regression, the CART, which is the classification and regression tree, which is very popular in R, K-means. And then this algorithm is tested against the test model, and we run it through a couple of cycles for improvement of the model, and finally before it is deployed. Even after the machine learning model is deployed, we need to periodically update it to make sure that this model is working fine, because over a period of time the variables change, the conditions change. So we need to continuously keep updating these models so that they are more accurate. So most of the model building happens offline and then they are implemented in the production. So here we can see the training data, and then we have the model training that happens, and then the model testing happens, and then we score the model to see whether the model is working correctly or not, or which model is working and giving us accurate results. So what are the different machine learning algorithms that are used? So the different machine learning algorithms that are used are regression models. Like for example, you want to find out how many more cycles an in-service engine will last before it fails. Now here we are using a regression model. The reason we are using a regression model is because the data is continuous. So whenever we have continuous data, we use linear regression model. And when the next question we want to answer is in yes or no, that means is this machine going to fail within 100 cycles of running? So here we are expecting an answer in yes or no. So here we will use a binary classification. Now when we want to have multiple answers to a question, for example, is the machine going to fail within 1 or 0 cycles, or is the machine going to fail within 20 to from 1 to 20 cycles? Will the machine not fail within 1 cycle? So multiple answers, we will use a multi-class classification algorithm. So let's look at how the data is coming from the machine and how we are going to run a predictive model against that data. So here I have some sample data from a machine, and generally when we have a data of for example around 33,000 rows. So here it is 20,000 and plus 13, that is 33,000 rows total. So you will split the data into two parts, that is a training data and a testing data. So if you see my earlier slide, we had spoken about training and testing data. And this training and testing data is what will be used for building our predictive, for doing the predictive maintenance of the machine. So in the next slide, I'll explain what this data means. Yeah. So the general approach for predictive maintenance is once we get the data, which is called as the input data, we will split it into two sets, which is the training data and the testing data, or also called as the validation data. So machine data which contains the failure information is called as the training data, and in the testing data we have the machine information without the failure information. So we will use our algorithm to test against this testing data and see whether it is correctly reporting the failure or not. Once we split this data into two parts, we have to follow, we generally follow this four methods, that is data cleaning and processing. So sometimes there is missing data. We need to convert the data type into a particular format so that the R software or any other machine learning software which we are using is able to understand the data. We do certain amount of data normalization. So once that is done, we do data labeling, the process of generating new columns for response variables. Now a response variable is the answer which we are looking for in a data. Like for example, is the machine going to fail or not? Yes or no? That is the response variable, and we call it as data labeling. Some other methods also which we use is called as feature engineering. Now I cover feature engineering later in the slide. Feature engineering is a process of creating new features or generally new columns, something like standard deviation or average of data, to help us predict the power of learning, to help the predictive model to get the answers better. Then finally we train and evaluate the model. So we check we use different models and check whether our models are giving the correct answers or not. So in our case, the response variable is the remaining useful life of the machine, and we can see how we are going to determine the remaining useful life of the machine in the next slide. So here we have the machine data, and like you see, we have split the data into two parts. The total data, generally the split ratio is 60 to 40% of the data or 80 to 20%. So we use 80% of the data to train the model, and 20% of the data we will use to test our model. So here we can see the data set. Here the 1, 2 is the machine ID from where the data is coming, and then the cycles are 1 to 192. So here you can see for machine 1, the data is running from from 1 to 192 cycles, and at 192 cycle it is failing. So this data is having the machine failure information. Then again for the second machine, which is machine number 2, the data is the machine is running from cycles 1 to 287, and suddenly the machine fails over here. Here we have settings 1, setting 2, setting 3. So these are the environment settings of the machine. And then S1 to S22 is the sensor information. So this S1 is various sensors information like temperature sensor or humidity sensor, acceleration sensor, various sensor information which is collected in the data that is coming in. If you see in our sample test data, we have not used any machine failure information. We have generally just given very random information from 1 to 30, and using this information, our algorithm should be able to tell us when this machine is going to fail or how many remaining cycles of failure is remaining. Now, the answer of this data is there in this sample of truth. So we have taken out this failure information from the test data and kept it separately. And algorithm should correctly predict whether this data is whether our algorithm should correctly predict the failure of this machine or the remaining cycles of life for this particular machine using the test data. So once we have the information on the data, we will move into data labeling. In between, we did discuss that one of the steps before data labeling is data cleaning. So in the data cleaning, the data set I have over here is a clean data. In data cleaning, we will be cleaning the data, removing certain data which is not in the correct format. So that kind of cleansing happens in the process. And then we have data labeling. Now, what we do in data labeling is we are trying to find answers. We are going to use the data label to find answers for our data. Now, here we want to find the remaining life of our machine. So hence we have added a new column called as RUL, which is remaining run life. This is our response variable. RUL stands for remaining useful life of this machine. So how do you calculate the remaining useful life of a machine? Now, if you see here, machine ID 1, that machine number 1, runs from cycle 1 to 192. So at cycle 1, and it fails over here. The red is the failure of the machine. When it runs from 1 to 192, so we are primarily taking the 192 and subtracting 1 from it, and we are getting 191. So in a sorted format, we are putting in this data of remaining life of a machine, and this is primarily being used for the regression model. Then after that, we have certain questions which we had discussed earlier. That is whether my machine is going to fail in 1 cycle or in 10 cycles. Now this information is being put in label 1 and label 2. So label 1 is for the binary classification for the information that we wanted, whether the machine is going to fail or not. So that information we have in label 1, and for the multi-class questions we have identified label 2. Now what we have done over here is we are assuming that we are splitting this data of label 1, that is for the binary classification, into 2, and we have based on our test data, we are saying that our machine is going to fail after 30 cycles, and we have put zeros and then we have put 1 over here. So in this way we build the data labeling to identify new data values which will be used when we load this data into R or any other statistical modeling tool. So In binary classification, we define, if you see in this row, label 1, which we are using for binary classification, we define a time window, and we are defining the time window as 30 cycles. So you can see it is from 1 to 30 cycles that we are here, that we are defining the time window. So if this engine failed at 192, we are defining the cycles from 190 to 131 as failure, hence they are 1. You can see from here, from 192 to 30, which we are defining as failure, and beyond 30 it is being defined as 0. Similarly, we are defining variables for the multi-classification window. Once the data labeling is done, the next step we do is feature engineering. Now, what feature engineering means is, let me go to this slide back again here. Feature engineering means we are adding new columns to this data that will help us improve our predictive model. So the process of creating new features that provide better or additional predictive power to the learning algorithm is called as predictive engineering. For example, we can use various aggregation techniques. Now, in this particular case, if you look at this data from S1 to S21, the moving average of sensor values is calculated, and we will add a new column that gives us the moving average of the sensor values. Another column we can add over here is the standard deviation information. Now this standard deviation information will be the values of the columns which are here. Now, after doing the feature engineering, we can use this new data to be used in our in our mathematical model. So just to summarize, the different steps that we have in predictive analytics is, once we get the data input, we do the data labeling, then we do the feature engineering. It is an iterative process. Sometimes we also do data normalization over here. Finally, when the data is loaded into the statistical model, we will be also doing scoring of the data. After the labeling is done and feature engineering is done, we are using the models. So the different models that we have here, which we can use, are regression models. So I have just shown an example of a regression model which is called as linear regression. So the different types of regression models are decision forest regression, boosted decision tree regression, Poisson regression, neural network regression. Now we are using regression models whenever the answer of the data we want to find is continuous. We will use binary regression models whenever the answer of the predictive maintenance questions we want to find is in yes or no, or in binary. So some of the examples of binary classification models are logistic regression, boosted decision tree, decision forest, neural network. These are examples of binary classification models. When you want to answer multi-class classification models, then we will use, when you want to answer multiple questions, we will use multi-class classification models like multi-class logistic regression, multi-class neural network, ordinal regression on logistic regression, and also two-class neural networks. Now these are mainly the jargons, but I have just tried to use two simple regression models which can help us answer the predictive maintenance questions. Now here the question we want to answer is how long this machine can last before it encounters a failure, which means we want to predict the remaining useful life of the machine. Our objective is to predict the value of the response variable. Now value of the response variable means the life of this machine. Like for example, will this machine last after running for 100 cycles? Will this machine last for another 20 cycles? Will this machine last up to 120. Now 120 is the remaining useful life, or 20 is the remaining useful life, which is called as the response variable. We use various feature engineering methods to get an answer to this question. And here question, and we use a regression model. The next model is this machine going to fail soon or not? Now this is where we use a classification model. Now in a classification model, the answer is yes or no. So we will use a classification model, and here we the objective is to build a classification model for normal and failure events based on the labeled data, and which is used to classify a new or unseen event. So the different methods of classification are logistic classification, classification tree, and neural network. Now, like I explained earlier, we can use different models. Now in linear regression, we can use decision forest tree regression, boosted regression tree, and Poisson's also. So here we have used only one. Now we find the same, we can find the same answer using different algorithms, and then we will compare these algorithms with each other and see their score. So we will use to answer how much longer this machine can run before it fails. We will check the accuracy, the precision, and the F score of the model before we decide which model we need to use. We can discuss more about the various models, and how these models are used and how they help in predictive maintenance. So like I said earlier, we have regression models. So decision forest tree regression. So here the decision forest tree regression is similar to a decision tree, which is used to getting closer to a answer of the predictive maintenance. Then in a neural network, it is more like finding the closest values or the similar closest values in neural networks. Logistic regression, in logistic regression, we use the log values to convert the linear data into log values, and the answers in logistic regression are range between 0 and 1. So you will generally get an answer between 0 and 1 when we use logistic regression. Now, the other questions that you will generally have is, what are the different learning resources that you can look at to learn more about predictive maintenance. So some of the learning resources you should look at if you want to implement predictive maintenance are a good understanding of probability, then machine learning. The tools we can use for machine learning are R, which is very popular and open source. Then for learning resources, you can go to Coursera, and there are many machine learning examples and capstone projects which are available that can enable you to implement this machine learning. Some of the interesting IoT platforms which you can use is the Microsoft Azure platform, then also Amazon IoT platform, then also the IoT platforms from IBM. So these are some, they offer free resources for a trial period which you can use and implement and check the predictive maintenance examples over here. Then in addition to this, the resources for IoT are IoT Analytics website, then IoTi. So these are two of the very popular websites I follow for understanding IoT and also looking at some examples of IoT maintenance. So the information I found from here, the machine data, I took it from the NASA website, and also some of the diagrams were from the Microsoft website and also from DeepSense.io. So if you have any queries or you want some solutioning around IoT or predictive maintenance, feel free to reach out at info@msystechnologies.com.
I mean, like in MSys, how we are implementing this one?
So in MSys, what we have done is we have implemented predictive analytics for one of our storage customers, and the reason we have not put a direct use case or shared any data of MSys is for India reasons, but I can briefly tell you how we have used predictive maintenance for a customer. So we have worked with a customer who produces large storage devices, and then there are IoT sensors that are fitted on this storage devices, and these storage devices stream the data, and we have used collection agents that collect this data and they are moved to the cloud. So we have a team of data scientists who work on this data to identify the various algorithms, and then these algorithms are implemented on the production. So what this algorithms or predictive maintenance models help us to do is, for example, predict in advance when the disk utilization is going to or when the disk is going to get full, or predict if there are any anomalies or that are there in the disk in terms of physical or hardware failures. Then also detect why a machine is running slow. So these are some of the areas in which we have implemented the predictive maintenance at MSys. I hope it answers your question, Manoj.
Yeah. And yeah, moreover, one more thing, like
Yes.
we have the big data kind of tools, right, like Hadoop and all. So
Yes.
is those tools also will be useful in this IoT, like except using the R language and all? So how
Okay.
those tools will be used here?
Very good question, Manoj. So the reason which you asked is how is Hadoop or other tools which are there useful in IoT? Now
Yeah.
there are two. Let me give you a detailed answer to this. One is IoT is only a data producer. It doesn't give you any answer. Make sense? IoT is
Okay.
only collecting the data for you. So now this
Okay.
data you need to store at a location. So that is where Hadoop or the NoSQL databases will become useful, because you are storing this data. Makes sense?
Okay.
Now you will use R as an offline tool to analyze this data. So when you are using R, you are not taking the entire data set. If there are about 1 million records, you may use only maybe 20% of the data to build your algorithm. And once your algorithm is tested with about 20,000 records or maybe 200,000 records, then you will apply this algorithm in production. So there you could use various Hadoop ecosystem tools like Apache Spark, which has an inbuilt machine learning library.
Okay.
So So if you see, there is a lot of interaction or an iteration that happens between these various tools. Make sense?
Okay.
So Hadoop and its ecosystem tools are useful in data storage, in predictive analytics, but model building and related work is done in R, which is done offline. But the implementation you did need Hadoop, NoSQL databases, Apache Spark, Apache Kafka, then you will use Hadoop to build a data lake. All these things are still there. So a combination of tools will be used here.
Okay.
Makes sense?
So in this, yeah, it's a very good explanation. I got the point.
Yes.
In this scenario, like, can we use this one Splunk and all?
So yes, Splunk is useful, but the only challenge with Splunk is it is a proprietary tool, and it is quite expensive for a startup company or an independent software developer, an ISV, to use uh, uh, Splunk. So an enterprise company will
Oh,
definitely use Splunk, because it is far more easier than the open source tools to use Splunk. That's a good question. Yeah.
okay, okay, fine.
Okay. So thanks, Manoj, for participating and asking these questions. It has been very interactive. And thanks for your participation. Do write us in on info@msystechnologies.com. If you have any questions, I'll be glad to answer them. And if you have any queries or solutions you want, we will be very happy to work with you collaboratively. And also, if there are any specific areas of predictive maintenance you want to cover in the next webinar, do write in, and we'll be happy to do another webinar on on the same lines. Thank you very much for participating. Have a great good evening, and have a great day ahead for my friends in the US. Thank you very much. Bye.